Okay, yesterday we were doing the travel time studies analysis. Okay, we did couple of problems in which we calculated the confidence interval. Okay, in both of them, and then we looked at this example where we calculated number of runs. Okay, so run means what? Number of observations. Okay, so moving on. This is another example where you see the travel time data, okay, and like the previous examples, the highway is divided into number of points, okay. At each point they take the observation, okay. So you can see we have 7 points. We have the length of the section is cumulative, so all of them are from which point? Which point is the start point? 1. Okay, 1 is the start point. So everything is from point 1. Same thing with the travel time, and like yesterday, these values are in minutes and seconds because they are from the stopwatch. Then we have 2 other columns which are for each section. Okay. So delay is for each section and the number of stops are for each section. Each section means what? Between 2 points. Okay, between 2 points. So this 10 seconds is between which 2 points? 1 and 2. The 30 seconds is between 2 and 3. Got it? Okay, so between each 2 points we have a section. Clear? Okay, moving on. This question has different parts. The first part is to find out the travel time and delay for each section. Delay is given, right? Delay is already for each section. Okay, so we have to find out the travel time for each section. Okay, but the travel time is given. So what should I do with this? Because this travel time is what? Cumulative. They want it for each section. So I will do the subtraction. Okay, so for each section I will subtract it. Walaikum assalam. So section 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and the last one, I don't know what. Okay. Now I need travel time of each section, right? For the first section, it's in minutes and seconds, so we'll keep it as it is. So it's more fun like this. Yes. Travel time for the first section between 1 to 2. How many minutes and seconds? 2 minutes, 5 seconds, whatever is given. Okay, because everything is from point 1, so no problem here. 2, 0, 5. Second one, you will subtract what? Tell me. 450 minus 2 minutes 5 seconds. How many?
2 minutes 45 seconds.
2 minutes 45 seconds. Okay, 4 minus 2 is 2 and 50 minus 5 is 45. Clear?
Yeah.
Any problem till here? Okay. Next one, so we will subtract 730 minus 450. 730 minus 450. 240. Okay. So 7 minus 4 will be 3 minutes 50, and 3 minutes 50 minus 50 minutes will give you 240. Any problem with anyone? Clear? I'm asking those who are doing with the calculator. Clear or not?
Yes.
Clear? Okay. Any problem with anyone? Okay. 910 minus 730. 140. 1027 minus 910. 170. 1154 minus 1027. 127. Okay, any problem with anyone? Clear? Everybody is clear? Sometimes you think it's clear, but then it goes wrong. So everybody can do this by themselves, right? Yesterday we solved one example. In the other section, somebody gave all the wrong answers. We finished the class because nobody else was doing it. He or she gave me the answers. I wrote it down and I went. Class finished. So if you are just relying on, okay, these numbers, okay, I know what is 2, I know what is 5. Can you, if you can do it yourself, fine. I'll move on. Clear? Okay. Just to get rid of my responsibility, 2 minutes, 5 seconds and 2.05, are they equal? Not equal. Okay. 1 minute has how many seconds? 60. So from 60 you have to start counting again. Okay, good. So now I have travel time. Okay. Second thing they asked me for, it's written in the question. I'll just not go to the side again. They are asking me for travel speed of each section. They are asking me for travel speed of each section. I already have travel time. I need what now? The length. Okay. The length is again given. Okay, but it is again cumulative. So the same thing which I did with the travel time, I have to do it with the length as well. So length in miles. For the first one, no problem, 1 as it is. Second one, 2.25 minus 1. 1.25. Okay, 3.5 minus 2.25. Okay. What is this? Yeah, 4 minus 3.5. Okay. Okay, same thing which we did at the time. Difference of 2 values. Clear? Okay, now you can calculate the speed, right? No problem. Speed in miles per hour. Speed should be in miles per hour. Your time is in minutes and seconds. So you need to do the conversion. So 1 divided by 1 is a length. I'm not taking inverse, okay? 1 is a length, 1 mile. See, okay? So now we have time. Time is 2 minutes and 5 seconds, right? So 2 divided by 60 to convert to hour. And 5 divided by what? 360. Because it's in seconds. Okay? 2 by 60 because 2 is in minutes. And 5 by 3600 because it's in seconds. How much? 28.8. Next. Again, the length will change, the time will change. $27.3. Next. 28.1. 18. 11.7. 31. Okay, this is what now? This is travel speed. Okay, I'll write travel speed here. Okay, this is travel speed. They are also asking for running speed. running speed. Okay, so I used travel time for travel speed. I will use running time for running speed. What's the difference? Running time without delay. So you have travel time, you have delay. You can just subtract it and calculate the running time. Again, minutes and seconds. Okay, it's 2 minutes 5 seconds and the delay is 10. So
1 minute 55.
very good. Next, 245 minus 30.
250.
And the next one is 240 minus 25. 25. 240 minus 25. 15. Okay, 140 minus 42. 117 minus 47. How much? 30. And 127 minus 14. Okay, so now we can calculate the running speed as well. Okay, so same thing, we'll use the same length but the running time now. Okay, the length will be the same and we'll use running time. Okay, how much? $31.3. Same. $37. Okay. Any questions? Clear? Clear? Okay. This was the question. Okay, we did this part. Travel speed and running speed for each section. Okay? But they are saying find out average travel speed and average running speed of each section. Is it average? Huh? We don't have what? Okay. The table shows, if you look at the top, it's a summary of 5 runs. Okay. So it's a summary meaning it's an average of 5. So it's already an average. Okay. These values are already an average. So whatever you are calculating is average of each section. No problem. Clear? Okay. Then they said, okay, plot them as well. Once you have the values, plot them. This is a plot for travel time and delay. Travel time blue line, delay red line. Okay. Which section has the highest travel time? 2 and 3. Which section has the highest delay? 5 to 6. So which one would you consider problematic? 2 and 3 or 5 and 6? Why? but that one has more travel time. Huh? It's a longer segment. Okay, that more time is because of the length of the segment. It is supposed to be higher. Okay, and that one, even it is short, but it can be much shorter if you exclude the delay. Okay, so there is a problem here. Then we have this plot between travel speed and running speed, the two values you calculated. Okay, again the blue one is travel, the red one is running. Which one is higher? Running? Always? All of them? Okay, can it be the other way around? Running less, travel more? Huh? Why? When there is no delay. Okay, travel time has delay, so it will always be higher. If there is no delay, then it can be equal to running, and that's it. In no way it can be less. Okay, so running speed can never be less than travel. In fact, running speed doesn't change. Running speed doesn't change, it remains the same. The travel speed can change because of the delay or not. Okay, if there is a delay, travel speed will be lower. There is no delay, travel speed will be equal to running. Clear? Okay, next part of the question, they are saying that they will hire some vehicles to do the travel time observations on the same highway. Okay, hiring vehicles for doing travel time observations. Which method is it? We discussed some methods, right? Methods for doing travel time studies. This one is what? Which one? The test car method. Okay, this is the test car method where you hire the vehicles and they can do the observations for you. Here they are saying that one car is available for 5 runs, 5 observations. One car is available for 5 observations. So how many cars should be hired? So I should know what? How many samples I need? Total how many observations I need? Okay, then I know each car will take 5 observations, so then I will calculate how many cars I need. Clear? Clear? Huh? Yes. What the number for number? What? Which question? So why would you get more than one number? Because?
Because we're only 2 equations and
Yeah, you need 2 equations?
you have 95 and
Yes.
90.
Yes. The 2 equations are for different confidence intervals. What confidence interval is given here? Look at the question. 95. The equation is solved. I will not use 2 equations, I will only use one equation, the one which is for 95% confidence interval, right? Okay. So, what are the other things I need? This is the equation for 95% confidence interval. Okay, so I have E here and I have S here. Okay, so what is E here? 3. Okay, because this is a tolerance level. Okay, what was S? Huh? E is tolerance. What is S? Standard deviation. Okay, S is standard deviation. Okay, so now we have this data in front of us. Okay, from this data we will calculate the standard deviation. Clear? Now we have seen couple of equations for standard deviation in the spot speed data analysis. These 2. Okay, the first 2. The third one is just a simplified version. So we have these 2 equations for standard deviation. Okay. The second one we have already used. In this topic, we have used the second one. Up till now, we were using this one or that one means the same thing. Second or third one means the same thing. We have been using that one. Okay, the last one. Okay, this is for grouped data. When you have group, okay, of observations, and then or you have group of values, and then you have frequency for them. Okay, do we have a group? No. Do we have frequency? In the speed table, you calculate the running speed, travel speed. Is there any frequency there? No. So there is no group of values and there is no frequency. So I will use the first equation in that case. Okay. In the first equation, you see x minus x bar upon capital N. What is x bar? Mean of the data. Okay. And what is capital N? Number of samples. Okay. So I'll go there. Okay, how many samples I have? How many samples? 5. How many values? Simple. How many values? 6 values, right? Each column has 6 values, right? Simple. So n is 6. Okay, now we have 2 speed values, right? Running speed and travel speed. Okay. We will use each one of them. Okay, we'll use travel speed and running speed. So give me the mean for each one of them. The x bar for each one of them.
Find the confidence interval for each segment. The confidence interval, is it for each segment or for the whole?
What confidence interval?
That's 95%.
Where are we finding it?
For a question. We want to find the number of samples.
Yeah. Number of samples doesn't require confidence interval is given, confidence interval is given, written. 95% confidence interval. We are not finding confidence interval. They gave us, okay, confidence interval means the two values you calculate by doing plus minus. That is confidence interval. This is confidence level. This is called confidence level. Precision of your data. Okay, so I want 95% precision in my data. Okay, I want you to calculate the number of samples which will give 95% confidence in my data. I don't want any values right now.
Why are we taking the mean of the values for the sections?
For what?
Don't we need to calculate the n for each segment?
For each segment?
Yes.
Where did it say that? They didn't say it. So.
Each
Find the
segment.
mean.
Huh?
Find the mean.
It's already the mean. Then what would you do?
Why are
It's already a mean. It's already a mean, right? Now we are finding out the overall mean of the highway. They didn't say for each section here. In the previous part, they said for each section. You don't want average for each section. Here they are not saying average for each section. Okay, so we are taking the entire data full. Clear? Okay, give me the mean values.
The mean for travel speed 24.15.
Okay, and for running?
32.68.
Okay. Okay, this is the equation for standard deviation. So x will be these values, okay, and this is your mean. Okay, so each of these values minus the x bar square. Okay, so and then you take all these square and add them here. Okay, then for the running speed, We'll take the values from here and this is your mean. Any problem? Again, just for the sake of clarity, you are doing this. Okay, and for the second case, you will pick the values from the running speed column and you will take the mean as 32.7. Yes. Which one? First one. Okay. Next. 2.5. Okay. Then the number of samples. The equation was 3.84 into s squared. This is my s now. Divided by e squared es3. Yes, how much? 24.6. For this one, you just change s. Yes. 2.7. Okay. So in the first case, how many samples I will actually take? 25. And the second case? 3. Okay. In the first case, they said each car will make 5 runs. So if you take 25 samples, how many cars you need for 25 samples? 5 cars, right? Each car is available for 5 samples. So for 25 samples, I need 5 cars. In the second case, you need 1. With 1, you can do up to 5, no problem. Clear? Okay. Any questions? Okay. You can see here we are doing test car method is for travel time study, right? Test car method is for travel time study. But what did we use for finding out the mean and standard deviation? Travel time? We use speed, not spot speed. It's not a spot speed. But we use speed, right? Why didn't we use travel time? Because of this, the tolerance level. We did one example yesterday where the tolerance level was given in minutes. So I used travel time. directly, no problem. Here the tolerance level is given in miles per hour, speed terms. Okay, so I can use that as well, no problem. But then everything should be in terms of speed, mean of speed and the standard deviation of speed and so on and so forth. Clear? Any questions? Okay, last thing, travel time contour maps. Okay, so contour maps have lines, right? Contour maps have lines which have same what? Same elevation. In this case, travel time contour map has lines which has same travel time. Okay, so you can see couple of lines here. These lines, okay, which are the concentric curves, these curves or these lines. So each of them has a value. You can see the value over here. Okay, the first line has a value of 15 minutes, the second line has a value of 30 minutes. These values are travel times. Travel times from where? From the center. Okay, so each line represents a travel time from the center. Okay, so if I come from the center and try to reach this line in any direction, how much time it will take? 15 minutes. And again, if I continue till the next line, so I will reach this line in how many minutes? 30 minutes. Clear? So you can see for developing a travel time contour map, I cannot do it using one highway or on one highway. I need the travel time for the entire area. You can see the entire area, right? The line is going in all directions. So that means you have to cover the entire area, entire region. Clear? Now why do we plot these contour lines for travel time? It is basically for this point of interest. This is my point of interest. Okay, so usually we want to see the generation of demand for this point, from where people are coming to this point. So usually your travel destination depends upon your travel time basically. You decide about your destination based upon your travel time. Okay, so you want to go to, for example, a mall, for weekly grocery or something. Okay, then you try to select a mall which is closer to you. You would not like to drive for 1 hour every week just for groceries. Okay, so you are deciding your destination on the basis of travel time. Okay, or you want to go to a clinic, you missed the quiz. Now we need the certificate, right? Okay, so just to get the certificate, who will go for? So you will look for the closer one, right? And they give it to you, unfortunately. So the people who are managing this point of interest can be anything: mall, clinic, hospital, stadium, whatever. Okay, but people are coming to here based upon how much time it will take them. Okay, so now they know that people from this area are more likely to come here than people from out of this area, right? They have the boundaries from which people are more likely to come to this point. Clear? So this is why it is done.